Welcome to qnawire.
In this problem, let's see here, we have steam supplied from a boiler to a high pressure turbine whose isentropic efficiency is 85%. Um, the steam has to leave the high pressure turbine at a saturated vapor at 1.4 megapascals, and the turbine is to produce 5.5 megawatts of power. Steam at the turbine exit is extracted at a rate of 1,000 kilograms per minute and routed to a process heater while the rest of the steam is supplied to a low pressure turbine whose isentropic efficiency is 80%. Low pressure turbine allows the steam to expand to 10 kilopascals and produces 1.5 megawatts of power. And we want to determine the temperature, pressure, and the flow rate of steam at the inlet of the high pressure turbine. Okay, let's see here. Let's see here. We have at 4, we know it's a saturated vapor and we know the pressure, so we can get the enthalpy and the entropy. We know at 5, in the isentropic case anyway, so this is through the low pressure turbine. At 5, we know in the isentropic case the entropy is the same as at 4, so we can get in the isentropic case we can get the quality factor and the enthalpy. Then we can use the efficiency of the low pressure turbine to get the enthalpy out of the low pressure turbine. So we then have, we can get the specific work done by the low pressure turbine. And that means that we have, that is this minus this. And so we know what the power is from this low pressure turbine, the power that we want out. So we can divide that by the specific work of it and get the mass flow rate through the low pressure turbine. And that winds up being 2.529 kilograms per second. Now, we know that we want, so that this is what's going through the low pressure turbine after we've extracted 1,000 kilograms per minute for the process heater. So adding 1,000 kilograms per minute and remembering to convert it to kilograms per second, we get the mass flow rate through the whole system as 19.2 kilograms per second. So this is the mass flow rate through the boiler. And so then we know and actually the mass flow rate into the turbine into the high pressure turbine. Now we know what the power out of the high pressure turbine was 5.5 megawatts. Yeah. So this was 5.5 megawatts or 5,500 kilowatts divided by the mass flow rate through there, which is this. So we can get the specific work done by the turbine, the high pressure turbine, which is the difference in enthalpy from the inlet to the exit, right? So that's this. And we know H4 already, so we can get H3 then. Now, we know H4 prime, so we can get, and we know P4, so we can get X4 prime. And we can get basically H4 prime because we know the efficiency, and we know H3 and we know H4. So we can get H4 prime, including with the pressure of 1.4 megapascals, we can get the quality at X4 prime. So here, again, here we are at a saturated vapor, but here we're in two phase, slightly in. And now we know the entropy at 3 is the same as the entropy at 4 prime. So we're kind of working backwards here. So, and we know, and again, we can get the entropy at 4 prime. So now we have the entropy at 3. We also know let's see, what else do we know at 3? we know we know the enthalpy and the entropy. So then we can kind of work backwards and get the pressure and the temperature there. And the pressure is 6.4 megapascals, and the temperature is 365 degrees C.